right, so we're going to look at factoring quadratics, and we're going to look at some special cases today. So I'm going to show you two different problems, or two different types of problems, where you can look for certain patterns that will help you factor a quadratic without having to create a diamond problem and without having to create a generic rectangle. So this first one that we're going to look at is this x squared plus 6x plus 9. Now over here to the right, I'm going to show you the pattern we're looking for. We're looking for an a squared plus 2 times ab plus b squared. So this pattern is our first and third values should be perfect squares. So if x squared is my a value, then a would just be x. I'm taking the square root of that. And if I look at 9, my b value is going to be the square root of 9, which is 3. So my middle value should be 2 times x times 3, which would give me 6x. And that's what I have right here as my middle value. So because I have that, the pattern says I should have a plus b squared. Let me try writing that again. A plus b squared. Or it would be a plus b times a plus b. So using that same pattern over here on our problem, our a value was x, our b value was 3, so we would have x plus 3 squared, which is the same as x plus 3 times x plus 3. So this pattern's a little tricky because you're having to check both your first term and your third term to see if they're perfect squares, and then you're checking the middle term to see if it's twice the product of those two square roots. So let's take a look at another example. We'll go through this on another problem here. So here's my second problem. Anytime my leading coefficient is not 1, in this case it's 9, I always ask myself, whoa, is there anything that I can divide out of all three pieces here? Can I factor any number out? I don't see anything that I can factor out. A 3 will factor out of 9 and 30, but it won't factor out of 25. So I don't need to worry about it for this particular problem, but I always like to check. So again, over here, I'm going to write the pattern a squared plus 2 times ab plus b squared. And what that's going to equal is a plus b squared. So let's check this one. So the square root of 9x squared is going to be 3x. That's my a. The square root of 25 is 5. That's my b. So my middle value should be 2 times 3x times 5, which would give me 30x. And that's what I have here in the middle. Perfect. So that means this rule would apply. It would be my a, which is 3x, plus my b, which is 5, squared, which I could also expand out and say 3x plus 5 times 3x plus 5. Again, you're checking your first and third term to see if they're perfect squares. And if they are, you're taking those square roots and you're doubling them to get your middle term. All right, so we've talked about this is where you're squaring a binomial. Let's talk about difference of squares. That's our next example. So let me scroll on down here. Difference of squares is a much more straightforward pattern. Difference means you have to have subtraction, which I have here. Squares means that your first value has to be a perfect square and your last value has to be a perfect square. You'll notice there is no middle value here. There's no x value. You're missing that. And that's okay. That's part of difference of squares. So if you have this scenario, if I take the square root of x squared, it's x. The square root of 36 is 6. And because it's a difference of squares, it would be x plus 6 times x minus 6. And that is the factored form. Again, you don't have to, let me see if I can write the correct number here, x minus 6. Sorry about that. You don't have to create a generic rectangle. You don't have to do a diamond problem. If you recognize that it's a difference, meaning there's subtraction, and your first value is a perfect square and your last value is a perfect square, you take the square root of each, and then one is an addition and one is a subtraction inside that binomial. Let's look at another example of one of those. All right, so we have 25x squared minus 16. Again, the first thing I look for is it difference? It is. This is a perfect square. That's going to be 5x. This is a perfect square. It's going to be 4. So I would have 5x plus 4 times 5x minus 4. I hope these shortcuts have been helpful. Have a great